go over just what we started on Friday. So when we were talking about tension, we were talking about the up forces equal the down forces. And if they didn't, then the weight would fall. Okay? If the down force was heavier. If the up force was heavier, the weight would move up. Then we also know the horizontal components are equal, because if not, then this would be moving. Okay? We were thinking of tug of war, right? So if tension 2 is pulling more, the weight would move that way. If the tension 1 vector is pulling more, then it would move to the left. So what we did is we set the horizontal forces equal. We constructed the horizontal forces by using alternate interior angles and then setting up our horizontal and vertical components. Remember, the horizontal component is T sub 1, or the magnitude times the cosine, the magnitude times the sine, and then we did the same thing for T sub 2. Okay, the magnitude times the cosine for horizontal, the magnitude times the sine for the vertical. So if you set your horizontal forces equal, you could solve that for T sub 1. You could also solve it for T sub 2. I just usually do T sub 1. Okay? Then you know the up forces equal the down forces. So what we do is we find the sum of the vertical components, which are the T sub 1 sine of 58 and the T sub 2 sine of 35. So we added those together, and we set them equal to the down force, which is the weight here. So once you have this equation, really what we're doing is setting up a system of equations with two variables and using substitution to solve. So for T sub 1, you can substitute this expression in, which is what we did. And then remember, I told you to be careful to make sure that you multiply by the sine of 58. And also, you don't want to round until the very end. So because we're not rounding to the very end, I use this dot, dot, dot to show that I am not using that rounded answer. Right? And then when you add those two together, you get 1.884, and that's continued. Then you're going to divide both sides with that 1.884, which gives you T sub 2. Okay? When you guys did that, did you get 26.54 or 26.53? Okay, let's do it. So I did the cosine of 35 divided by the cosine of 58. It's really not going to make a big difference in our final answer. Times the sine of 58. Okay, and then I'm going to go ahead and add that to the sine of 35 degrees. Okay, so I have the 1.884, and then I'm going to do 50 divided by that answer. Yeah, so rounded, this is really 0.53. Like I said, in our final answer, that's really not going to make a difference, but it is just going to change these decimals a little bit. Okay, and then once you find your T sub 2, you can substitute T sub 2 into the equation from step 1. So you can do the 26.53, and really you can just use this exact value and multiply it by the cosine of 35, and then divide it by the cosine of 58, and then you will get 41.01. Now, when you look at the picture, you can see that these are vectors, right? T sub 1, T sub 2. So your final answers are going to be vectors. So for T sub 1, the vector created is T sub 1, 41.01, times the cosine of 58 degrees, and then 41.01 times the sine of 58 degrees. okay? Because that's your horizontal component and that's your vertical component. What we're doing now is we're just plugging in the values from our tension. Okay, and then something else we're going to have to pay attention to is where T sub 1 is going. What quadrant is T sub 1 pointing to? What quadrant? Quadrant 2. In quadrant 2, what do we know about the horizontal and vertical components? What are their signs? Yes, okay, so in quadrant 2, your vector should have a negative A value and a positive B value, right? You guys agree that in quadrant 2, your A value should be negative? Okay, so then we're going to make this value negative, right, to represent its position. So then your T sub 1, okay, is going to be times the cosine of 58. And you get 21.73, so it's negative 21.73. And then here you can use the 41.01 times the sine of 58. And that will round to 34.78. Okay, so that's your vector for T sub 1. So this is one of your two final answers. Okay, the other one is going to be for T sub 2. So for T sub 2, your tension is the 26.53. So we're going to do 26.53 cosine of 35 degrees for this one. And then T sub 2, which is 26.53, sine of 35 degrees. Okay, and then I'm going to calculate both of those. Now, for this one, we're in which quadrant? We're in quadrant 1, which means they're both going to be positive. Okay, so I have 21.73. That looks familiar, right? Why does that look familiar? It's the same number as the top. They're just what? Opposites. We're going to talk about that. Okay, and then this would round to 15.22. Okay, so if we look at these numbers and analyze them, we can see that your horizontal components, when you add them, what do you get? What's the sum of the horizontal components? 0. Okay, and that makes sense because we do not want one to have more than the other because the horizontal components should be equal, right? Okay, so if they're opposing, then it would be 0 and they would be equal. Now, what about the vertical components? What is 34.78 plus 15.22? What's the sum of the vertical components? Why is that important? That's the weight. So the sum of the vertical components for this one were equal to 50 because that is the weight or the downforce. Which again makes sense. Remember how the up forces have to equal the down forces? So these two forces together are going to equal the down force because those are your up forces. So that's a really nice way to check to make sure that you did everything correctly because the horizontal should always be 0 and then the sum of your vertical component should always be the weight. Okay, so I'm going to give you a few minutes right here to try 73 and 74, which were the tension problems. Hopefully you started them because we actually got really far on this. But if you need a couple minutes to finish them, you can. And then I'll explain to you what we are doing next.